And before we run the simulation, we have to make sure that the output that we want to observe is identified as an output cell. So select the profit, total profit, monthly profit, okay, and select define. So it's selected, and when you click, risk output is inserted in front of the sum. So at risk will know that this is the cell whose values it should gather as we run the simulation. Okay, now we are ready to run the simulation model. So let's say that we want to run 10,000 simulations. Replication is 10 and we want to run it one time. And we can go into settings and then set some values here. One that would be um, useful is, okay, so number of iterations, number of simulations. Okay, so here multiple CPU simulations, you should really set this to automatic. So when it is possible to use multiple threads in the CPU, at risk will use that, and that will speed things up in terms of running those replications. So that's one thing we can do. And now in sampling, the initial seed is an important piece of setting that you want to consider. Now if you say fixed and then give a particular seed, any seed if you like, then by repeating the same seed you can generate the same output. So output consistency will be there if that's what, if that is important. So it will generate the same exact results. But in a real model, you want truly um, realistic output, then you need to choose randomly. If you choose randomly, the random seed is chosen every time you run. So every time you run the model, you'll get slightly different results. But in a pedagogical setting, it's a good idea to put it to fixed, okay, so that what I get is what students will also get as results. Okay, click OK, and then simulate. Okay, now simulation is completed. Now we have results. Okay, so here we have increase in movie going rate. Okay, what are the values that were simulated? So it gives you the values within 90%. So you want to increase the probabilities. Okay, make it uh, okay. So like that, then you'll see what are the values that were simulated for increasing movie going rate. So it's in that range, and you can okay, then you click on that one, then that will give you the distribution of simulated values for the sensitivity factor. And once again, by default, you're going to get 90% interval values. So you see that 90% of the time the simulated consumer sensitivity was between 1.757 to 4.2443. Okay. Then here is the output or profit. You click on that, then you again get a profit range. Okay, for the 10,000 simulations. Okay, once again, you can increase or decrease this. Okay, and you also have information here. Okay, statistics. So minimum, maximum, mean, 90%, the sampling error, okay, and other pieces of information. And then you have the percentiles, 1 percentile to 99 percentile. You can change this to legend with statistics. So you have only one simulation that we ran, so there is only one set of information here, and this is a summary of what the statistic grid gives you. Then we have the tornado. Okay, so this tornado map shows us what happens to our profit during the variations of different inputs. So we have two inputs, movie going rate and consumer sensitivity. So here, increase in movies per month. Okay, so we already saw the variations in that in the chart. So when we looked at this chart, right, automatic. Okay, so here the increase in movie going rate varied anywhere from 5% to close to 50%. As it changed, okay, from the low value to the high value, what happened to the profit that we were interested in? That's what is given here in the tornado. So to select the tornado, you have to select the output and then select tornado. Then this tells you for the first input, okay, high values, okay, the highest value gave you a profit of or loss of 43 million, and small value, the smallest value that we simulated, the profit or in this case loss of 32 million. And this gives you the range of values for the profit, okay, for the range of values we simulated here. Okay. And same for the second input value. Okay, smaller. So here high input is on this side. So larger values for consumer sensitivity gave you the largest value gave you a loss of 41 million, and the smallest value gave you a loss of 30 million. Okay, and these bars are arranged in decreasing width. So the largest width, so that means that input had the largest variation in the profit, that's at the top. And then the next smaller width is plotted below it. And then if you have more inputs, then the smaller and the smaller widths get plotted below it. So it starts out with a really broad bar at the top and smaller as you go down, and that looks like a tornado, and that's why it's called a tornado map. So in other words, this tornado map tells us which input variable contributes to the largest variability in your output. So it's a kind of a risk hierarchy. So this increase in movie going rate is the one that results in the maximum amount of variability in profit. So that is very sensitive in terms of affecting your profitability. And then the next one is consumer sensitivity. So it gives you a hierarchy of risky input variables. And you can also get that from the tornado contribution to variance. So we look at the other tornadoes later on. So here it gives you what is the contribution. Okay, so 53.2% of the variability comes from um, the this input variable and 41.3% from this.